How's it going, everyone? Welcome. We're Gonzalez here. Today, let's going to talk and explore and run some code about the RxJS, especially of how can we now manage its source of events from the user interface, and then we can stream that to our server and vice versa. So far, this is now an extensive topic because it all starts with thunk. What is thunk? And this is a concept that you can see a lot in Redux, and this is state management as a way to now is have a deep understanding of how all of these things works behind the scenes and what all of these concepts mean, what they represent, and what are the problems that they want to solve. So, as a UI developer, if you want to be a UI specialist, it is important to understand that JavaScript, which is the language that you're gonna build all of this kind of user interface on the web, using the web platform, and also you can do that on Node.js, this JavaScript runtime to run server. So the idea is, by looking and exploring is the way of how can we deal is asynchronicity or concurrency in our applications, and concurrency and asynchronicity is all of these tasks that can happen and overlaps at a time. This is also something that when you go deep into this, for example, how now the OS handle the processes and threads via the scheduler or the context switching, it is now just to open up how previous software engineers and computer science actually now find a way to, or they create now a technique that back then it was something that works. So for example is, hey, if a process needs to get in to be evaluated by the OS or by the CPU, a process must switch out so another process kicks in. So why am I mentioning this? Because this particular mechanism is so expensive that there are now other techniques, and this is expensive because the OS need to keep the state process, and also so the previous states, the several previous states, and store all of the data in that process, and that include is the stack, the program counter, the register, the memory as well, or the heaps or the memory. It also needs to do some virtual pagination as a way to know what'll be is the next process to be loaded into memory. And because this process is so expensive, there are several techniques like thread, or like I'm remembering this because this is something that we're actually doing that in our JavaScript applications. So for example, the cooperate concurrency known as coroutines, and coroutine, and let me see if I can remember. It's like coroutine and in flows. No, this is not flow. Is coroutines, and this is interesting because there is a knowledge gap here. It is fiber. That's the another concept. So you have fiber and the coroutine. So this now trades or this is less expensive even in low switching context. So it means that if a process needs to run, it needs to yield control so other can run. So this idea of yielding, because that's what I mentioned, this idea of yielding control to another process so it can run, is now at the application levels to carefully design a long-running task and breaking down into is to create a long-running task and breaking down by yielding periodically. So this this is perhaps some concept that is broad and too vague, but the point here is that because this is something that can happen now at this is a mechanism. Imagine this like something that, for example, when you open up the fridge door or your house door, you know, you insert the key, or even if you pass some car on that, so you hear now the feedback, beep, right? And then the door opens up. So all of this is our inner mechanism of how now things works in the context of processes and threads. As you can imagine, that this context switching, or this manager here to decide whose set of a statement is going to get in here, is because so expensive that now we as developers, we have now this particular techniques to deal with the concurrency in our programs, like coroutines, or like coroutines and sorry, in fibers, where it now it is make less expensive to, or it makes or it is cheaper in even lower context switching, because now it is the application level as an author, co-author, to define a long-running task by breaking down and yielding periodically. This is something that generators actually do. And the reason of this is because now we can define all of these state machines. All of this is series of flows in which a machines can be. That's pretty interesting when you actually understand and dive deep into this concept. This is a reason why perhaps for those who are listening to me right now, it may say, hey, whoa, slow down. It's quite hard, it's quite deep. It's like, what the French stuff is all of this? The TLDR of this is to, as a JavaScript developers, we need to know how to handle the asynchronicity in our applications, and that is by exploring is how all of these techniques and tools that we have in the language and where they come from and how can we use it, right? It's just to understand that, period. The syntax, all the kind of stuff may vary. It's not written on stone. But the point of this is those particular tools and patterns help you to solve some of these problems. So similar like a screwdriver, I think it is, skew, exactly. So similar like a screwdriver, all right, that help you to that particular set of a nail. Why you translate that into Spanish? Yeah, similar like a screwdriver, right? Or yeah, similar like a type of a screwdriver, flathead, Phillips. Oh, it has a name. Okay. So Phillips, interesting. According to who? The engineering choice. Flathead, Phillips, Torx, Robertson, Hex, Postgren. I only know these two. And Robertson. Perhaps Hex. Alright. This is the most common use, the flatheads and the Phillips. So similar to this Q driver, when you have these tools, whether it's callbacks, thunks, promise, generators and iterators, as well as the observable, which is something that we're going to discuss in today's video, each one of them help you to solve these asynchronicity problems. So you have now callbacks. The trade-off of this is it has now this inversion control, one, and second is that they're not easy to reason about it, because this is not the way of how we plan stuff. That's one. That's what we have now, and also is the time coordination that needs to be done is something that is quite challenging. Now, thunks help us here by saying, hey, let me now abstract and eliminate time as a concerning factor of this function, that at some point you will get that data. So even though that this doesn't solve the problem of inversion control, in other words, is that, hey, by passing this control set of instruction, I don't know when that will run, but I want to that not run too many times, too late, too often, too soon, or too early, too late, too often, too few times. I want you to preserve the data context as well as the error. Now, this guarantee is something that Promise gave us to here, because now you can think of this as a callback manager, as an event listener of that you can subscribe to. By the time that data is done, then you now get that value. So, and also there is an inner mechanism that allows you to do that. And this is now talking to the event loop, which is the responsible to actually now queue all of these different tasks that will happen at some point in the future. And they have now to queue on the browser, which is the macro task or the callback queue, and the micro task. The micro task is where all of these promises are being resolved. And they add now all of these different callback that you pass to promise. They have more priority than the callback queue, and this micro task or the promise task or the micro task is something that it will go to the another callback, or it will go to the callback queue unless there is no more until there is no more functions inside of that queue. Now, why this is important? Just to understand now this mechanism and how the things work is also open up your mind as a way to know how this stuff actually work. And when you look, for example, at stuff in JavaScript right now, like the asynchronicity, or this async and await, you can now understand why the things actually works, and that is by allowing you to define is all of this series of states that these machines can happen, or in other words, all of this different state that these functions can be, right? So that's why we look at generators and iterators and what generators allow us to do, because at the end of the day, generators give us now the ability to describe this state machine, which is a fancy way to say, hey, these functions allow us to describe is series of flows from one state to another, to another, to another, to another, and then descriptively list out the transactions out. So by using now the generators in combination with promise, where inside of the generation or the generator, it allows you to pause and resume the execution of this function, the generator function, which is something that you can do on normal functions, because that's part of the nature of JavaScript functions. They run to completion. So with generators in combination with promise, we can say, hey, I want you to yield a value, all right? In this case, yield these statements, and now you are from the generator pass control to the promise, and by the time that that data is now there, you can now call that generator using an iterator, and the iterator is just a way, it's a design pattern typically for stepping through data, in our case for stepping through series of flows, which is amazing. Oh my god, completely. And by the time that that data is there, it's going to trigger that the iterator will call that generator, get into this function, resume the function execution, receive that data, and then continue to evaluate until there is a next yield. And then finally until you have now a return. So all of this is just to know how you can deal with generators, how you can describe series of flows of doing this kind of stuff, and especially for the asynchronicity. And I mentioned all of this topic that the fiber and coroutine, which is just alternative mechanism of the context switching, because this is now at the responsibility of the author or the application developers to define this long-running test. Let's say you want to define is now several API calls, and then now yield them periodically, right? So that's why here it becomes quite important to understand that, and this is just for dealing with single values. But what happens when we need to deal with a series of eventual values? That's where we have now observables. So promise is not helpful here because it's just allowing us to resolve as a single value, all right? And promise is something that comes from a programming language called E, made by Mark Miller, one of the TC39 commit on among other smart folks as well. And they have now in that language a thing called promise features. But now here in JavaScript we have now this stuff called promises, right? So promise only help us for dealing with single values. Most of the time as a UI developers, we need to handle a series of eventual values. That's why promise, that's why observables kicks in, and because this is not natively on JavaScript, at some point it will land to the language, but right now we need to rely on the RxJS, which is a library developed by smart folks at Microsoft. And now observables is on a draft states where they based on these RxJS libraries among other libraries out there. But the point here is that this library, this conception, this way of thinking of how can we deal with this series of events as a way to given these collections of events, by the time that that sort emits those events, we want to get one of them, apply some transformations on some series of steps, and then distribute that in our system. So that's exactly what RxJS allows to do. So observables is just a way of, if you want to boil down into more technical aspect, it is this aspect of what you can think of this an observable that is an adapter hooked onto an adapter hooked onto an event source that produces promise every time a new event comes through. Okay, so that's why we look here at RxJS as a way to now where we are here, RxJS, Where the F is this? Creating observable, there you got it. But it's this one. That's why we're looking here at RxJS. Okay, you can think of RxJS as this library like Lodash, but for events. And here we look at this particular concept of observable subscriptions. What is an observable? It'll allow you to define is this series of events that can happen, and then you can describe it by yielding values or primitive and objects using auth or iterators, generators, promise, or even observables with from. And we also look at the difference of these two, the auth and from, and how you can create observables. You can also create your own observables. And when it comes to listen to those events, we need to subscribe to that. And there are two ways to subscribe that. You have the legacy one, you have now, which is now passing its 3 functions, but now you have is the new one, which is receiving is or passing is an object that has the next, complete, and error. All right, and each one of those property you pass now a function. Period. So with that, all right, by defining is this. As you can see, this is how you can now subscribe to this. This is how you can subscribe to this. Okay, you can either is or doing this by passing is just a single function, all right, which is most of the time what we're going to use, like this, or to handle now some errors and all that kind of stuff, right? So by looking at how you can create observables and how you and looking at the observables that we're going to use a lot. So for example is from events, which is one of them. So for example, from event, from fetch API, bindings. We also look at how can we create is now a counter with observables, which is mind-blowing, but it's important at least to understand that, especially if you need to handle is this concurrence, this series of events. For example, Angular developers actually know this very, very, very well, this particular pattern. Exactly, so from events, bind callbacks, and now from fetch. In this video, we're going to talk about from fetch, and then how can we explore all the most common operators in observables, right? Which is looking at the interval and time, how you can now generate a series of eventual values, and then also how you can stop that by unsubscribe that, and the common operator to work when you're receiving is a single value, and then you want to apply some sort of transformation, some sort of steps here. So for example, pipe that allow you to now, as the name suggests, pretty much like Unix, is putting all of these different operators. Okay, so stacking different operators, so for example, take, skip. It takes the first nth elements or skip the first nth element. Map, okay. If you want to actually is, as you know, map, what it does is applies a transformation to each one of those elements. Filter, if you want to actually is get those particular values based on that. Redux, that applies now a Redux function. In other words, you're going to apply this Redux or this step through all of the elements, and then once that is over, it's gonna emit you that. Most of the time you want to use this scan, because this what allow us is to now apply is a Redux function, or in other words, based on the previous value that we accumulated, now apply that transformation and then generate that value. Similar for the other one, you know, pretty much like in the scan. That's what they call scan. So this is what you most of the time wants to scan. And tap is for applying some sort of side effects. Let's say you want to do a console log, or you want to call to a div elements. And then now combining all of these operators, all right, with take until, skip until, how you have to be careful with that, manipulating times. In other words, is by creating now several or manipulating time and merging timelines. Okay, is by creating now a different observables where you can now string series of values at some point in the time or at an interval. It gives us now the ability to actually, by using this merge of for joins or concat as a way to now put all of this series of elements here. And I think this is quite interesting as a way to see how you can now merge all of these different observables or strings of events and then apply something. So for example, if you want to now merge two observables and only get that value, that's why we do this. You can do is a merge map, just like merge, combine all the children into one string. It's like give me all of them, combine into one string. You can do is the concat, combine all children in one string, but work through them one at a time. Switch map, say, hey, drop what you are doing when a new child emits for the first time. Okay, and then exhaustMap. It say start working on the first child, but then ignore everything else until you are working on completes. So it's like, hey, make a pause here. I'm gonna get this, and then I'm going to emit that. This is also something that is quite interesting when we look at the, I don't know why they didn't put it here, which is something that I supposed to like interesting, they didn't put it here. But also we look at the debounds. Okay. Yeah, interesting. Yep. But we look at the bounds and throw. Okay. So debounds and throw. That's quite interesting. So debounds and throw. So debounds, it will wait until events are stopped emitted. Okay, and then do what it needs to do. Do what it needs to do. Right? Do what it needs to do. Okay, this is debounds. And then throw. It will let you pass an event, and then after an X amount of time, do what it needs to. So what is the subtle difference between debounds and throw? Most of the time you want is debounds for autocomplete features, right? I want debounds here for this autocompletion feature that are gonna now, for example, when the user is now raging clicking on that, or when the user is now typing a lot of stuff, I'm gonna wait, chill a little bit until the users calm down, and then I'm gonna run the things that I need to do. For example, an API call. And throw, all right, is when you want to let that event pass initially, and then after an X amount of time, all right, I'm gonna do what you need to do. This is also part of this. We also look at this higher high order observables as a way to now to deal with this, so to abstract the values of an observables, the value of these several streams. Okay, so mergeMap or concat or switchMap and exhaustMap. Okay, and how now can we build is a timer with our switchMap. Okay, and here we look and explore is, this is another map 2. Yeah, for example, map 2. Yep, map 2 as well. And all right. Okay, cool. So let's get into what we really care in this video, shall we?
Really, everyone's favorite part of front-end engineering is the APIs. Now, I want the record to show that when I found this unreasonably sized collection of dog facts using the fetch API, not trying to. Also want the record to show I had weeks to avoid making this pun, choosing literally any other data set. So where? It wasn't intentional, but I committed to it. So yes, we would fetch dog facts. Don't have it. Okay. You should have an API that's known as an HTTP API at localhost 3.3.3. If for some reason your API server doesn't work, I also have a very server hosted as well. They're both options. So we're going to use OS HTTP://localhost 3.3.3. And this API has some fun features. Basically, it has query params that it can make links. Yeah. Well, the API doesn't need that. So it has the ability to add a delay to it, have it fail intermittently, and all sorts of fun stuff like that. So we can recreate bad situations. But we have that in this. So we'll go over here, and we have the ability to do something asynchronously. We know that from fetch given observables, iterating a counter is neat, but not good enough. So let's look at what this would look like with an API request. Real API. So we have this in place, and we've got this fetch button. We'll start with this fetch button. It'll fetch you some dog facts. Who doesn't like dog facts? So we'll say fetch, which again, I apologize for nothing. And we'll say from event, we'll just click on that fetch button in this case. One of the interesting things too is, on one hand we're writing vanilla JavaScript, on the other hand, knowing exactly what to do with this, it's effectively how for reason. I care about when these given events change. Here are the
I'm gonna work here now with these streams of data. Exactly, this observable here. I'm going to work with this observable here, and it means that you can see here. You can see here is to say, hey, because I'm going to work with these streams of data, I want to now only works or the bounds.
When that click comes through.
So when that click comes through,
I want to measure, right?
I'm gonna merge map, and then merge map is say, hey, okay, so here you are create, okay, so you want us to create now is an observable stream here, or an so what you're doing is that by the time I get this value, because what I'm doing here right now is, let me actually jump to the code right now. There you go. Excellent. Perfect. Is this updated? All right. Let's get into the code here. Let's get into the code. And there you go, much better. Okay. Okay, more cleaner. And let's go to the go. ETK client, accident counter, portfolio next.js. Mood. No, it's not here. Must be on cursor. RxJS fundamentals. Go graph Redux. Etiquette client. Enterprise UI development. Quite close. Fundamental plant integration testing. RxJS fundamental. Here we are. Okay. Okay. All right. Are you with me? And no, this is enterprise. Is this one? Okay. So again, what we want to do here is to now get these streams of data from an event button. Okay, and by the time that we receive that event, I want you to now cast a observables to fire up a exactly what this is interesting. So look at the flow here. The flow will be is to capture the event. Okay, the flow will be capture the event. I don't know what you do this, but anyway. Exactly. Capture the event from an HTML tag, say bottom. And then now run a promise. All right. So and then or fire an HTTP request with a data. Okay, and then receive the data to show it on the UI. This is now all of the stuff that is gonna happen behind the scenes. Is that I'm gonna capture this event from the user, and then I want to now fire that HTTP request, and by the time that is there, or not, we're gonna assume it's the happy path. By the time that is there, okay, Now I want to get the data and show that to the user. This is the feedback. And this is something that requires a lot of libraries and stuff like that, you know, in order to make that happen. Because we already have all of the infrastructure needed. For example, fetch button, stop button, clear errors, clear facts. We have all of the infrastructure needed, so we can focus on the observable stream. Now, how can we do that? Well, first we want to capture that from event. Not sure is it gonna, okay. From events, like this. So we're gonna capture now from the target, which is from the fetch button, I think it is. Yeah. And I want to now is listen to the click event. And of course, now pipe this by now creating is an observable. And you may wonder is that how you can create now an observables. Okay. Well, by saying the from fetch, okay, because from fetch is gonna create now an observable for us, which will be is with the endpoint. Okay, it will give us now. So I think by default from fetch it perform now a get request, something like that. As you can see, it's using now a fetch, right? Behind the scene is using now the fetch API, which is of course not here. It's globally available by the JavaScript language, but it's something that is provided by the browser or the platform specific that the JavaScript is run. You have now the input and the per subscription here, and this is exactly what it's gonna do, right? It'll say, hey, by the time that you get that, I'm going to pass now a function and say, hey, if the selector exists in the selection to do this, it is abortable false, and then the subscription completes. So in other words, it stop the observables there, you know. Otherwise, complete that. If there is any error, so you want to abort that and handle that. This is quite interesting, very silly, but behind the scenes is now keep tracking of this state, allow you to control now is an observable, and define all of these different variables to control this, right? Or in other words, is variables to keep track when state happens or not, right? We also create another, you can see it, there you go. So back in our code here, we say, hey, the from fetch endpoint, which is this, it's gonna create now an observable, which is quite interesting, but because we want us to now extract is the value from this observable. One way to do that is by saying is merge map. If you are hearing this huge noise, it's because I'm doing laundry. Give me a second to actually to close the door. let's get into this. All right. Okay, good. Now, yes, because we are creating now an observables and we want to extract the value of these observables. That's why we create now this mergeMap. I'm not sure how this mergeMap works. It says this is now a project, result selectors and concurrent. I think this mergeMap must accept is a function. Project here. Yeah, it's a function. So yeah, it's a function that is going to receive now is the observables value from here, right? Now, what does it mean is if we take a look at the mergeMap, so mergeMap here, that's right. If we explore about this mergeMap, it take exactly the value and the index. That's interesting. And then it's gonna give you now is the value of T, and O extend from observable input, whereas the project, which is the value in the index, the result selector, number, outer value, inner value, observable of, outer index, number, index, inner index, number. Okay. The first stuff is, the first parameter is now a function called project. The second is the result selector can be a number or a function that is going to give you now the value or the type and the concurrent, which is now a number that is infinite. Okay, so this is gonna give you now is the value of this stuff that you pass here. So x interval, and then you can now is okay, so what we are so this is interesting. Okay, so basically what we're doing is to create now an observables here. Okay, and here there's just by piping, this is another way, but here what we're doing is that, hey, I want you now to create a new observables that is going to be resolved, whether it is success or fail, if it's good or wrong, if it's complete or not. And then, all right, the question is, I want to now pipe here that value that I'm gonna get from here. You can say something like this to actually be more descriptive. What it's doing here is now anytime it's going to receive an event, I'm going to now call this observable. I'm going to create a new observables, and then I'm going to extract the value using the mergeMap. Okay, which is I don't know what this value might be here at this point, because, for example, okay, let's go to explore now the docs, because if we take a look, dive into this, we say from fetch, this will gonna return, this will gonna give us is now a inner from dot subscribe new operators, or handle error. But the thing here is that what we're going to receive from fetch. Let's go explore the docs. And okay, the inputs or the requests, okay, and then we're gonna get now this observable T. In other words, it's gonna return now is a string or a request. Now this is from fetch, and we're gonna receive is a response object. Okay, yes, we're gonna receive is now a response object because behind the scene is using the fetch. It makes a lot of sense. We're gonna receive now a response object that this response because is containing is the data. We can say something like this: response. But this response it doesn't have the value there yet. We need to is transform into a readable human format, JSON. The question is that how can we do this? You know, because at the end of the day, since we're going to return is now a response.json, where this is a promise, and we need to wait for this. All right. The question is, shouldn't we handle that? Why are you so slow, bro? Okay. Exactly. Return is a response JSON. Okay. Return is a response JSON from that. So
because what I want to do is return from fetch. I want to turn that click into a fetch request. Just use map. It's a good idea. Doesn't want it. Wanted a fetch request. Want an observable. So we've got this kind of comparison. So we've got mergeMap.
mm-hmm.
So
But you're doing is that here from fetch. Okay.
Yeah, the facts.
Which is I'm piping here. If I say pipe, and then I want to now from this is to get an observable or a promise. mergeMap, that's what you do in this. It's like, hey, I'm going to now, I want to, anytime you need to deal with a promise or an observable, and you want to extract the value, mergeMap, switchMap, exhaustMap, depending on the case you want to work with, this is how you do. So in this mergeMap, right, where we are receiving is a response, I want to now get the value from this response. All right. I want to get is the value from this response. Is here, bro. Exactly. I want to get is the value from this response, and then I want to subscribe to that. But I need to define is this will be now a fetch observable. Okay, and by the time that I do this, I want to now pass that data to this HTML for that. In other words, by the time I subscribe to this, I want to then now pass this data. Okay, to the what? Add fact, right? Add facts. So add facts is receiving is the data. So because they have the same signature, we can do is something like this, which is the 0.3. As long as the input signature match, that'll be good. Just like that, exactly. And if we run this piece of code like this, and then we navigate to our browser from here, we say, hey, let me navigate to the browser, to RxJS, like this, enterprise development, RxJS, there you go. And then I do is this doc facts. So if I fetch docs, that actually work as expected. This is style fetching. This is mind blowing. This is mind blowing. And again, we are all assuming the happy path. You know, we are all assuming is the happy path. So the thing here is, if we are now doing this for mergeMap, with mergeMap, we're gonna call this allo. You know, you select all. I mean, is you spec here, and then you do the fetch from docs on the network tab. As you can see, you are actually firing all of this, right? The problem of this is that you can, you see, the problem with this is that you can now quickly is you can quickly now is firing up a, yep, you can quickly now is, well, flood your server with all of these requests. So you're flooding your server. Perhaps you don't want that. So this is using now mergeMap. If we use, for example, exhaustMap, okay, you do the same. Okay.
Relax. Put them on the page and go back. Put up to kind of like 2 seconds, roughly 2 seconds. Because again, it's hard to simulate every network condition. Always exactly.
Oh, okay.
Let's add a little bit of delay. So in this case, we modify the API a little bit. Let's say delay. Let's say it takes 2 seconds to respond. And just to make things worse, we can add this element of chaos, where kind of like 2 seconds, roughly 2 seconds. Because again, it's hard to simulate every network condition because it's always exactly 2 seconds slow.
Okay, this is not to simulate, is this. To simulate is a delay, 2000 seconds, and chaos true, right? Like this one, you got it. But this is interesting. And slow network. You see, if you do mergeMap, if you do a mergeMap, you say, hey, I'm going to take all of this stream. But if you do exhaustMap, you say, hey, wait a single moment. I'm gonna deal with all of these requests until you chill, until I get that response from the server. Until I get that response. Okay, because exhaustMap is saying is like, once it's complete, then I'm going to do the next one. No matter how many events I'm receiving here, because I'm doing this exhaustMap, I'm gonna let this observables to be complete, and once that is done, I'm gonna do that. Oh my god.
This is gonna be a little bit different. So go ahead.
It's all about the observable here.
See, you press a bunch of them, they kind of come in, and they're kind of loading at different points, all over the place. But like these are random dog tags. They're going to get a sampling of them no matter what. What would I want to use if I want to be like, we're getting you some dog tags, relax. Put them on the page and do that.
Exactly. With the exhaustMap here, with exhaustMap, we are waiting for that observable to complete. Okay, before taking any other before taking any other child, before taking any other events. Exactly. We're waiting for the observable to complete from fetch, exactly the observable that we define inside of this. From fetch. Before taking any other, exactly, and then take another event. Exactly. This is quite interesting with exhaustMap, whereas with whereas with mergeMap, we're saying is fire, okay, or fire the observable. Exactly. Fire the observables every time an event pass through. Pass through. That's right. This is quite interesting. Very, very interesting. Very, very, very interesting. Very, very, very interesting. I don't know. How to come and go from keyboard shortcut. Yep. How to come and go from keyboard shortcut in so how to come and go from keyboard shortcut in Yeah, how to comment code from keyboard shortcut in. Yeah, how to comment code from keyboard shortcut in cursor. Okay, okay. This one, this one, this one. Okay, awesome. So this is now with mergeMap. Okay, let's go to now back to the code here, like that. Here is a way to explore this. Chill, because we are not firing anything right now. So chill, chill, chill. Screenshot here of this. It's going to record this particular process here. Okay. Vamos una vez mejor para que se vea todo. This is one. This is with mergeMap. Now, if we do with exhaustMap, now if we do this with exhaustMap, all right. Now, difference between or use cases of mergeMap, you can say, is exactly from fetch API or network use cases. So you can say something like this: network use cases. So by saying is this one or mergeMap and exhaustMap, if you need to fire whenever, if you need to fire a request whenever, yeah. Network use case, mergeMap. If you need to fire a request whenever an event pass through. Okay, and I think this is quite interesting as a way to now build this kind of stuff. Screen recording and all that kind of stuff. This is our last one. No, it's because it's this one, but this is from the exhaustMap. Exactly, and this is from mergeMap. If you need to wait for a observable to complete, if you need to wait for an observable to complete, fetch data, for example, it is fetch data, and I know why observables are so powerful, especially for backend developers. Huge, bro, huge. If you need to wait for an observable to complete, it is fetch data, right? Yeah, and then take another event. If you need to wait for an observable to complete, and then take exactly to complete, and then they take another event. This is what it is, which is finder with this one. Network use cases. That's interesting. That's very, very interesting. Very, very interesting. Very, very, very interesting.
Yes, basically, more clicks goes down to the random pop quiz, which we all know the answer. If I wanted to switch to the newest one,
Switch.
Switch map will be like, I don't care about the root facts I just requested, new facts. They're not real. Doesn't really matter. Like, so in this case, the exhaustMap is the Redux. Okay, so like, what happens if this fails? Like, we already have times. Depends on the API. Response is okay. Now we're using mergeMap, so we do need to return it. Right, so we couldn't do something like we want to do kind of like the node style. This did not work. because with that switch map or exhaust map, it's expecting that it gets user.
Mm-hmm.
This promise is going to turn into an observable. This is just an object. Yep. Perfect. Yep,
Exactly.
wrap it in an ob, and now it's an
If you're an observable, wrap it into an object, and now it's an observable.
Cool. We've got that error in place. Could say facts can come through for the error. We can kind of almost handle this like mergeJS style, where we could say if there's an error, set error with the error message. Otherwise,
Mm-hmm.
so put our facts in there and before and this is one minute. This is good for errors where we want to do something. We still haven't dealt with the idea of like what happens if like systems go poorly. You kind of see that well. And it's one of the advantages that we get from HTML. It will actually deal with
The facts
let's try this out.
and script.
So you see something was wrong because occasionally the API for this one
Exactly.
Two.
There you got it. Good. Git commit with a message. Or need to add that. With exhaust.
That is the question was can we use the catch error operator? But we have to kind of change the way because again, we implemented
Exactly.
this
Git
because,
push
origin,
origin fetching fetching from API.
But that doesn't mean we can't throw it. Right? We're well within our rights to throw an error.
We already pushed those chains to this.
You can say throw a new error.
And then we now create this one. A new comment.
Now, throwing an error, we created a bad thing for ourselves. If one throws an error, it's kind of like throwing an
Exactly.
catch it. Right. Not my best analogy, but we're gonna go with it. So the question was, can we use catch error? We can. We just need to make sure that we throw errors in the case of it. So we have an operator called catch error. And instead of letting the observable error out, what it does is it allows you to catch it, right?
Catch it and return
So
something.
say like return, just basically that logic we had before.
Mm-hmm.
We'll also just pass it. This should do the trick. Throw the error. Mostly because we'll play a fun game. Why didn't I catch the error?
Because you throw a new error is not an observable. Throw a new error is not an observable. So you need to.
Yep. Yep. So it was on the outer observable. It's really this inner one that so that is a common practice. The inner one blew up, nothing followed. So you have to catch, just like in JavaScript, you have to catch the error when you're through this. Oh, you can catch it. Oh, because we are console.
You are in the network. Need to look at the network. Need to look at the network.
So yeah, we're seeing on the screen big change. We see something went wrong. We're also seeing not because I didn't blew up. We see the network value. We can see nothing blows up in the code. Simply we got the fact that the API. But we recovered. You'll notice. And we gave it a shot. All right. So here is the tricky part. You have an API. It works. Show an error message if there's an error. Awesome. Clear out the error. What I probably do is we try it again. big deal of it, there's nothing. See if it works again. What if we wanted to retry? How would you do this? Do you have? Let's say I want to try everything. We all know.
The bounds.
Let's whatever we want to try, a certain number of times. Not that's maybe do one. Let's say we want to do something. What would you do with this? Maybe do one. Let's say we want to do something. What would you do with this?
Oh, would I do while? Yeah, while loop.
While yeah, you basically have to switch, right? You iterate over and over. You can do that. Like everything in RxJS is a thing that you can do. In JavaScript, you can also write your own virtual bound too. You can do whatever you want. Maybe we don't need to screen goals. Maybe we talk about it. One of the options that we have is this ability to we can say, okay, I want to retry 4 times. So now we'll go ahead and we'll, if it fails for some reason, let's try it again. And this one fails 1 and 2 times, so like ideally you should see a success rate. Let's see if we can do it.
Exactly. No.
Failed, and then try it again. Successful.
Failed,
Failed.
then try it again.
Right, it probably won't fail 4 times because it's like API that succeeds roughly half the time. But for the most part, like now we can basically implement retry logic incredibly easy, right? You have a pretty like reusable piece of API fetching code. Fetch it, throw an error. If you get a 4 or 5 times, it's promise API doesn't give that default. It'll catch the error and you can choose what you want to do with it gracefully. If it does, if it gets through all 4 times, it will eventually hit the catch error and you can do something with it. But otherwise, we can't choose to retry.
Catch error line is exhausting.
Yeah, you know what it was? It's really awesome there. It's like, oh, that's an error, that's an error. That is sure bubble. Like this one, it's fine. Because I was console error because I see it red and yeah, this one is retry. Now, let's make it fail all the time so that it, like this will eventually make it through its 4 retries.
Mm-hmm.
Right, you can see, tries, fails, because there's the initial time plus 4 retries, right, and long. So you did catch the error, you did have that something like Irish reset. But you turn this to a console one, just to be
You need to uncomment that.
this section. Right? So tries, and then we hit
Mm-hmm.
so here's a try. You know how to
Yep.
screen. You know how to fetch data. Changing number on the screen, not that impressive. However, you see a world, this is where this is weak, which is like, cool, fetch the data, then fetch it again every so on. Right? 30 seconds. A minute, if you're working on the same dashboard, right, you want to show
You want to show is some data, real-time data.
right? So depending on what you have available, you might have to take it. So one is simply to refresh something. Right? So how would we combine a little bit of what we saw with starting and stopping observable with theoretically pull up some data and every so on and so forth refresh. And that is definitely a probably more realistic use case than an account. Right? But effectively, right. It's the same concept.
Exactly, it's just a timer.
For it to be something.
Just a
So,
timer.
Okay, how would this work? I'm going to remove my error back in. Because one of the reasons why I have it here so I can make this one continuous piece of logic. So we have this ability to theoretically fetch.
To fetch data from that, and then I'll retry that.
Great candidate, especially because if you find a world where observable is getting a little gnarly because it's getting kind of big, You do the same thing you do with any other piece of code. You take your big, ugly piece of code, break it into smaller components, and hide them in components. Right? And that is how you develop software. So let's take this logic of fetching, because we don't want to do it more than once.
This is how you develop software, man. Basically, is that you take this big giant file of ugly stuff, and then you do that.
This logic, all this logic here, and we'll pop it. Great, awesome. Now, our exhaustMap really becomes
Fetch data.
this is what we're doing with whenever we're thinking fetch, right? Simply exhaust mapping this factory function.
This factory function here is going to happen.
Similar to what we saw when we returned one for throttling, but it's the same thing we did with map. We've got that. This fetch button seems good, but instead of having it immediately trigger, we're going to start the process at a regular cadence, fetching that data. So we'll go and set, like we've seen this before. We saw it earlier. We map to true in this case. Let's make sure yep, map to is available. Sweet. And then the other button is the stop button. Stop button.
Creating an API data stream.
So now we've got very similar to what we already connected with the counter before. We have the ability to make true events, false events. What's the next step? Do both things. Mergeable, right? It's called a backstream. Maybe in computer science it's hard. We'll merge the fetch event and stop event.
Okay. Then I want to pipe them to apply some sort of operators.
exhaustMap, because we only wanted to deal with one at a time. But in this case, these will be synchronous.
Okay, this is to create an API streams events. Yeah, showing something under the counter is not that interesting.
Right? I care about the most recent one. I don't care. If I use a mergeMap, I'll keep making more strings. Right? Every time I start and stop, I'll create that many more nevers or fetch events. What we want is a switch map, so we only care about the last time they said start or stop. We don't care what happens now. We deal with the current situation.
So this is you want to actually now switch map to say, hey, only take me is the last one. Okay.
Cool.
Okay.
Let's see.
If they should fetch.
Or should I fetch?
Yeah.
And
If they should fetch, then I'm going to now is to return the.
that fires immediately. They hit the button. It's not interval will wait that amount of time before the first event is emitted. Timer fires immediately, then again at whatever cadence you want to. So timer, fire right now, and then again in 5 seconds. So we'll say
Pipe the
and
fetch function here.
I could do this all. Subscribe is just going to be the final event in this case. What I really need to do now is clean up the facts of the error message every time, right? In this case, we want to hide the error message. I want to clear the error message. This fetch is only going to give us the final value, but the subscribe is only going to give us the final value. That's not useful. So what we'll do is we'll pipe and we'll say tap, clear the errors. Tap. I can do these both the same. I'll just close my two. And now, this is where we'll put that exhaustMap.
Which is, hey, I'm going to now create this for
They
the.
should be fetching
Every immediately.
UI, and we will go get new facts. Right now we could theoretically be like, actually I'll keep facts until we get the new ones. And if we should not be fetching, switch them to
Then never. Exactly. So hey, switch to this observable here, which is never, or emitting that never.
Start and stop buttons, fetch and stop buttons. Based on that, it's either going to point us to observable, or it's going to keep making that API request. The cool part about this is not only is it going to create the API request, but it has all that retry and error catching as well, right? Or if they say I'm no longer interested in getting new dog facts, I mean that's a personal choice. Respect that. Then we switch them to the never stream, silence, so they can toggle back and forth between these. So we don't need that anymore. So we'll say fact string.
It's something that we're going to subscribe and then add facts. Okay. Whenever value comes through, with exactly whatever value that comes through, whatever it can be never or the data from the exhaust map, the data from API, right? Wow, debugging this shit might be a nightmare.
This one always goes back. It's not really making sense. I might want to keep some of the, I guess I'm not showing here in this case, so I'm going to before, probably useful. But let's one of the instances. The code that I had before was like, okay, there's an arrow there. I just said, like, I have an arrow facts, and it's an object. So again, this was
Is it causing errors?
This API still has the line. Like I said before, we could choose to wait until we got the new ones and make sure that's when we start playing around with it.
This coordination here is something that is powerful, bro.
You can even do it to subscribe. I have in fact go play around with this. But if I took out the line, I said, well, so what's cool about this is now I have complete control. Use just regular JavaScript functions. It's not like, okay, set this interval, clear this interval, and now I'm going to have this stream. I can listen to it when I'm ready to listen to it. Stop listening when I want to stop listening. I'm not thinking about intervals or anything like that. Again, like the framework where you might make this kind of interesting for yourself is component amount, number amount, use effect, what have you. Like start listening, stop listening. So here they're just kind of refresh.
It's gonna refresh that. Mm-hmm. Exactly.
Stop it, and then we stop.
And it will stop to fetching that data. Mm-hmm.
Right? So you combine it with a lot of concepts. It's just kind of, let's celebrate ourselves for a second. Talk about it.
Absolutely, man.
We have a fetch situation where not only will it
We were able to catch the error and fetch it. Not only that we fetch the data, we'll retry.
we can then also take that and set it to import point time. So we took everything we learned about the counter, setting timers for starting and stopping flows. We took everything we learned about async, and we put them together. We actually,
Holy moly.
so you can start to take these things and snap them together.
Especially for dealing with this data that needs to be done at some points or that. And I get it why a lot of this, especially trading application, that kind of stuff, actually are doing that.
And I think at this point we're going to places along the way that is going to be less useful than more concepts together. So let's just look quickly at CUI.
Holy moly, bro.
There is a fetch button in case I want to manually. We're going to say, as they type in here, I want to show this. Cool. So, let's think about what we need to do. Well, we know that we need to get the value. We've dealt a lot with buttons, but we are going to need a value. So let's go ahead. That's nothing super surprising here. So our search stream is from the event search field, which I've got cached already. And really we care about input. So they put the input in there. That's when we want to jump in and deal with it. But as with most things, like you go to use like React, you know that it's not just the event that you need, it's the event type. So what's in this search field? So we can actually grab a map of that. This is not an observable, it's not anything asynchronous, it's simply a value. We go ahead and grab the event. Alright, so now, whenever there's input, we haven't subscribed to it yet, but we'll get it and we'll get the value of it. Well, input's a little, yeah, we'll get the value of input will be cool. And we have two issues. merge mapping, like kind of map that we have. You guys are making. Let's try merge. Let's do it. Let's map. We'll take the search term, but we know we want to make a fetch. And here, we'll say return fetch the endpoint. And this is, I have to know that the endpoint is look. So we want to change this a little bit. We're going to put that in.
Map each one of the events. So you take all of the event that you gave to take here. All right.
Yep, we don't get a lot of data. That'll be just we're going to know that much. Right now, all we know is these 25 projects. So search from fetch, and then we'll say plus right. That's going to be a little bit problematic. So we also need to go ahead and get the submap to fetching. So it's a pipe, then we merge map in there, and we say
The response from this.
response.
Exactly. The response from this will be a JSON, right?
And when that's all done, we will throw the results from the page. We'll add. I want to actually just, so if you looked at the API before, I want to actually just get. So there's an operator, another, I can use map, the other thing I can use is pluck. Pluck, you might have seen from Lodash, pluck will just grab a given field. So in this case,
Block.
a little bit data.
Interesting. Block. Pokemon.
Results.
Interesting. Block.
Yeah, results. Alright, great. This is not gonna work perfectly. You know that? Some of you are like, we're not doing that yet. We're gonna see how it behaves. Let's make sure it doesn't blow up at all. So it works great in a very fine situation, right? But what happens if we add just a little bit of chaos? Right? What happens if we say delay could be like a second, with a little bit of fuzziness. Right? So actually we'd like to see another actually trying to do. And like sometimes it works out, you can see that it's kind of all over the place. Right? Other requests that we're doing, even I have Pika in this picture, right? Because the requests are coming back at the wrong time. We don't care about the previous requests.
Switch map. Mm-hmm.
And the one thing that I want to show you that's kind of nice from using fetch is if we go in here, we've got a network request.
But it actually
You
is.
actually see that from fetch is actually full on canceling these requests. So every time we use a switch map,
Full on canceling.
not only are we not listening to the response, we're also just full on canceling.
We also full of canceling
What
that.
would we do, just kind of tying some previous things all together, what would we do if we wanted to wait a little bit of time before we even set that request?
We will use the bounce here. Exactly. We can use this the bounce.
Bounce time. Okay, so here we could say when an input event happens,
I want you to the bounce time
bounce time. Let's
for 3 seconds. 300 milliseconds.
So now, instead of, like, we can cancel all these requests, they're still going out. The server doesn't know what they're canceling. The browser knows, the server doesn't.
The browser knows,
so
server
now
doesn't.
Okay, only when they pause, right? Kind of pulling what we saw before when we went into that notification. When they chill out, about 300 milliseconds, then we'll do this again. And then we'll go fire the request. So now if we take a look, nothing until we stop.
And do we stop everything?
So now you don't thrash the real cancel those requests. You can simply say only do this while. The other thing that we can do, and this won't actually do anything, it's kind of, I just want to point it out, is we have this operator called distinct,
Distinctly change.
which basically won't our switch map, and the fact that input fields only emit when they change doesn't really do a lot for us, but I kind of just want to make you aware that it exists, so we get that value. It's a distinct until changed. So now, even if
this value that we're getting here,
so it's the same value, like the bounce. If for some reason you get to the, I mean, this could actually work. It's like the input field is going to change. But even after 300 milliseconds, if it's the same value,
if it is the same value the last time, don't say another request, man.
Right. So now we're really trying to trigger back into this. Right. So chill out until they stop for 300 milliseconds. Then go get the value that
We're trying, chilling. We're definitely are chilling with the backend here.
Otherwise, go with the most recent request.
Otherwise, go with the most frequently received. Get me that value from that, and then now it get me if that value from that.
Right. Now, I just want to again talk about like if you started with that. Right. But as you build up all the small pieces, right, all these things that we have done along the way kind of all begin to snap together and become one inside. I just want to show the name. So you can do that. You can try to read it. It's kind of like beginning, which is sometimes you hit the API. You don't get all the data. Sometimes this is intentional, like maybe it's a list view and you have some of the data and you want to decorate more data. Sometimes it's just the API that you got, and it's totally on the back into the backlog to give you that API. Lay down. It's there though, and you gotta do it. So these are both the situations, both the positive, happy version of this and the sad version. Regardless, how we might solve for it is what it is. So instead of searching on a keystroke, the functionality that we want now is going to hit the fetch button, and we're going to get like result Pokemon matches. And you saw before, we only got the name, the ID, and in this case, what we want to do is we want to get that Pokemon, show that data, and then we'll find out more. We're going to go to individual one by say Giga 5. You can see I get a whole bunch of other information, most of which I don't care about, some of it. Well, so we want to change this a little bit. We're going to steal from a little bit of our previous code as well, but
this is loading data over time. That hey, by the time you get this data, I want to do this another one. I will do this another one, and this is defining this state machines, man. So defining this state machine as this one, and then this another one, and then this another one, and so on and so forth.
Instead of an autocomplete, we maybe got a list of names. In this case, what we want to do is we found one to search for, and so what we'll do is, but first, we don't know the ID. We don't know the ID until the search results. We just want of the search results, the first one that matches. The first one that matches, we then want to go get the subsequent data for it. Right? So we do have one more little helper function, which is running now called Pokemon. That just shows it's just a different configuration. It just shows a different thing. So let's think this out. We have our search, and that is now going to be from the form. And what do we care about with the form? What action?
From event, from our search. From
Input word for search field. This is
input word from search field.
so submit.
Submit.
Right. So we submit, and then that will trigger our pipeline.
Our pipeline here, exactly.
Right, so there. Now this is interesting because we care. We hit the form. We care about the input. Right. So we could say
The fortification, man, is this because it's powerful when it comes to create stuff, bro. It is powerful to create stuff, man. To produce something out good. It's this one, and this one, and this.
Now we should have that value because we don't care about the event checking value. We care about what's we'll go and we will get the Pokemon just like we did before. Right. So this, I think most of this will work, right? And you want to switch map because this way they hit it multiple times. We get the most recent one. And you can argue maybe this should be an exhaustMap. because we'll get what they got the next time regardless of changing again. Yeah, so whichever one makes you happier. Like again, like sometimes it's nuance on the behavior pattern. Knowing that both are an option, how they behave differently is the important part. Which one you choose to use, again, okay. So what I will probably do at this point is I want to break out the act of getting the Pokemon that matches the search term from getting the addition. We know that search / Pika will get me everyone that matches PI KA in the beginning, and then /25 getting the data about Pokemon 1. So let's just separate those out so that our observable does not become. So we'll say const search Pokemon. Do the search term. This will be very similar to what we have now. Right. And from there.
And then you're gonna return is the.
It's basically this part right
Hmm. But you still return is that as an observable, my friend.
So we have the ability to trigger.
So you're composing is that.
You can take that. You always add this chaos back. And then.
Because you have because after all you're going to generate is a value from that. Yeah, you should definitely store that in variables.
Right, this button makes sense. Now we have basically factory functions that will produce observables.
Because exactly, you are producing observables.
Very similar. We use promises. We will have you just.
That's one of the reasons why you should create that, man.
Sad later. So now we know that when this happens, we want to go. We have the search value. So what's the first thing that we want to do? Yeah, we want to get the first one that matches the search term. We want to display it on the page, and then we want to go and subsequently get all of them. Right. So what operator comes next in this search? Because right now I'm just mapping the submission to the value.
So by mapping this value from here, okay. Wait, what?
Switch map, you want to go make a request, right? So take whatever happened.
So
now the value is what's coming in here.
Mm-hmm.
We know that this takes a search term, so we could actually theoretically. Pretty will handle this for us in a second, but let's give ourselves some more time.
You should pass this a search value for that.
So we'll say switch map, what do we switch map?
Search a Pokemon.
That should
This will give us back is an observable of where we can actually get that.
We've got that in place. We're going to turn subscribe just to the console log for now, so you can see it before. Sweet. Open up the console. Visualize that slightly. So if I said
It actually get that particular value, initial data.
Right. We now have kind of what we need. Let's go ahead and I'm thinking at this point, since we have that data, let's do some data transformation. And say, cool.
Which is cool. Give me is the Pokemon only. All right.
Pokemon.
Block.
That, which is now get a raw array. Now
Exactly.
we don't want the first one. Two ways I can handle this. One is I could use a map and just run the first one, right? The other one is we know that mergeMap will take anything observable like and use from, put it between streams, right? And so what happens if I use from on the right? Observable like and use from, put it between streams, right? And so what happens if I use from on the right?
It creates an observable.
Very good. Use from on the right, right?
Get a stream of
Right.
observables.
So I could use something like. So I could use a map where I just grab the first image. It's totally a thing I can do. Or I could say,
So whatever value that I'm getting from
So it's saying,
Pokemon.
cool, map over this, return the thing, but then turn that array to a stream of values. It's effectively the same thing as doing. Then merging it together. Right? We're saying like take that array and stream them
Okay, so take that array and then stream that one by one.
So go ahead. So mergeMap, give me the series.
So it's like taking all of this. Okay.
Review. Now I get a stream of every Pokemon that starts with letter P. Now, in this case, I could just render those one by one. I no longer have an array that I have to iterate over. In my DOM manipulation code, I can just one by one as it came through, but I only want the first one. What can I do to get that?
Take one.
Take one. Take one, we'll get just the first one. Review, fetch, and just get Bulbasaur. Just not an array of one, just a raw object. Take one is common enough, but there is another operator that's basically the same thing. It's going to take a while to guess what it is.
First.
Right. So first.
First.
The other part of the is review. Boom. All right. So now from the search, I am switching to the most recent.
I'm switching to the most recent one.
Putting all of that same logic that I had before. I'm getting the first one through, and now we could theoretically render it. Yeah, that's just a DOM manipulation code because trust me, watching me write raw DOM manipulation if you can. One second. Right, you can see it loads. This is interesting.
Loading additional data.
Now that's hard coded in, because basically unless we have the initial data of the object, it shows that. Right, so now what we want to do is, upon loading it, we want to then take that information and fetch additional. Well, and so what would we do? We have two options. Right? We kind of want to, this will render it, and we'll get the Pokemon back and do more stuff, right? This tab takes whatever you gave it, passes it along. Fair? Well, what else do we want to do?
Is to now actually call the another one.
Switch map on the get Pokemon, right? Now, the merge map took it all figured out. It's problematic. The switch map is probably our right choice, so I would not do the thing where I recommend.
So whatever values that I'm gonna get, I want to ditch whatever value that I get. Okay.
What we can do is we can go ahead and we can get that one as well. So we've got the Pokemon in this case.
Exactly. We got the first Pokemon here, and then now send that.
So we say switch map, and then we'll return one number. And then theoretically we could call them. What we need to do at this point is put it onto that Pokemon object. So we've got that. Let's see what we have. So later I get that data. I could theoretically target that part of DOM. But the other tricky part is like, I could do the first, I could render to the page, then I get this data. I could also subsequently do that as well. There's a few ways that I can target that. That would probably be enough time. The other thing I could do is I can kind of try to do them a little bit both at the same time, right? So what if we try, so we take our switch map again, and we're just going to store them in variables. Now we know that if we want to do anything in RxJS, we have to turn on our values and variables. It's kind of like asynchronous function. Once you start playing with async, everything has to be async. Right? The second you have one synchronous function, just so we'll say, and now we've also got, go ahead, we can say,
Which is the single value that we're getting here.
our additional data.
Mm-hmm.
So we wanted to, our additional data is get that Pokemon data with that Pokemon.
Okay, see, because the merge map is not transforming all of this data that we're passing here into an observable, and then take that. Mhm. Holy moly! To transform these streams of data, especially if you have an array. Mm-hmm. So here what it's doing is to say, hey, this is Pokemon, alright, because now this is a single object value, and then I want to transform into an observables and say, hey, additional data, which is get Pokemon data, which is now okay, get Pokemon data, where you're going to perform that async request, map that data, map the data with the Pokemon, and then merge these two streams, the Pokemon and the additional data.
You see that it loads right into assets. Now, there is an issue here where if we slowed this down, we'd be getting all of this, we'd be doing all of this, and theoretically, we can use a switch map or an exhaust map. Finish what they did for some reason, exhaust map, this all together. If we look at this, let's review. We go to the first one, and then we're going to kind of fire. We're going to take showing the initial one. If it comes back super fast, cool. Do both, but then kind of give you both pieces of data. Because when I give them in a stream, that problem with the pipe, cool, you had the Pokemon and that data. Then you do the second one, then you only have the second piece. Here we're just going to kind of like have a Pokemon, maybe we'll get more stuff, and then I'm going to merge them both here, and then keep them data so you can kind of update the data. You can probably do this with a scan as well, but they're just kind of different ways.
Name some.
Kind of last the many different ways. Just how hard it is. Right. If it's your first loading indicator, yeah, sure. Right. It's one of those things where it's like fast API.
Async UI, loading data over time, and creating API data stream. Holy moly.
So what we're going to try to do here is we're going to create a fake API responsive control via this number of milliseconds. We will choose when we want to show a loading. Because again, if it's back real fast, we don't immediately show when we're immediately taking it. Right? That's the first one, basically. The loading indicator. The second one is you can, like, by solving for the I only want to show the loading indicator for things that can load in a second, you introduce a new problem, which you just move the problem forward in time, which is what happens if you show the loading indicator after 1,000 milliseconds, you got the width. Cool, everything happens, let's go data. So we'll show it. Well, we show the data, we will fetch, we'll show the loading, we'll fetch the data, and then even sometimes what I would do for suboptimal. I would put time limit. So this one.
Oh, okay.
Trying to lie gently, like, you know, like, we're just trying to
Okay.
So, you think, 1 second. It still is about how to say, like, here's transmissions. You're here for all new things. Doesn't have for time. You're setting a whole bunch of date variables. Trying to keep it safe. Like, okay, I'm going to set this one to true. Then I'm going to set date.now plus the amount of envelope. And then when this thing comes back, I'm going to say date.now is greater than the blank. I'm already frustrated. Right? So to give ourselves tools to manage all this, again, it's all JavaScript code. But to give us abstractions. Questions?
Often use subjects in your data.
Yeah.
There's a question of how often we use subjects. So subjects are very simple. Like you have a subscription, and you can have multiple places. Now, theoretically, I'm technically using a subject, right? The share, like I'm effectively turning a colon to a role. So there's two ways to answer this question. One is something that builds map and spell all the time. Spell stores are subjects, right? Because spell handles reactive things out of the box. Commonly, they use them instead of like Redux stores. In the actual like coordinating some events, not as often. So a subject, just to be clear, is both a subscription and an observable. You can both say call.next, all the things we did originally at the very beginning, call.next, .subscribe, .next, .complete, .error, and so on and so forth. And then things can also subscribe to, which is one object that is both observable and observable at the same time, right? And so those are useful if you have pieces of your application that you want to listen to one core data store. So my application on a day-to-day basis, those are self stores. When I did React, I didn't use it at all because Redux was my store, right? Effectively, the reducer was the shared link that everybody talked to. Actually come in, we do all some advanced, you see right here, like figure out what should happen, and I will subscribe to these things. So it's useful as a data store when I know what changes, right? But in terms of like a longer flow and coordination, this is theoretically one right here, and some pieces like that will come up when I need to share.
For coordination, man.
Again, I don't want to fire two data. As often as like you see them in data stocks. As often as like you see them in data stocks. That's what I think in Android. That's the premise that I use. Those are not subjects, they're just subject-like. Behavior subjects are the ones that give you the vast value. Either replay subject, replays with all the values that you've gotten. Async subject, gives you I've never used an async subject. I don't know why I would use an async subject. But yeah, behavior subject is very much like this. Effectively, not only is this a subject, this is effectively a behavior subject, right? If you're a new subscriber, here's the last thing that I said, right? If this share replay, had a huge number, it could be all the things, right? So it's a way to kind of catch up with previous things.
Exactly.
So yes. So I think commonly the place I've used it for is a React application, and so in that case we have Redux observable, and Redux observable is effectively middleware for Redux, where you set up these things called epics.
Middlewares for
But an epic is just observable is effectively middleware.
Redux observable.
Where for Redux, where you set up these things called epics, which sounds really cool. But an epic is just a piece of middleware that every single action flows through. So you can have multiple epics in each environment. Every single action flows through every single epic. And what you do is effectively you filter, or there's a type of action is effectively filtered. So when every single action flows through, then you find yourself where you can like deal with that, and you can also merge map it to other actions, right? And okay, they said, hey, I'm looking for the API data. Cool. We're loading the API data action, which then we actually deal with, or whatever. And then when that comes back, then I want to fire out a action that was done with here's the data to right? And so we have to look at SendGrid, the marketing manager, we basically use that for every single action flew through that because SendGrid at the time, still today, used its public APIs for all its client-side applications, right? But those public APIs weren't necessarily built for building UIs, right? So a lot of times we would have to kind of do APIs for all these client-side applications, right? But those public APIs weren't necessarily built for building UIs, right? So a lot of times we would have to kind of do a lot of orchestration and dancing with those APIs. Like, cool, actually, these three APIs, which they all come back a certain subset of there's data loading and put it all in place. Redux Observable is really great, but also if you think about it, like familiar with React, I think I mentioned a few times during this course, you can use observable, right? Like passing an observable that uses use effect, subscribe to it every time it emits, have some nice statement that they use the way you want, and then unsubscribe. Right? So you can use them basically, and that's why we focus on just using JavaScript to kind of take it away from that. Most courses on Angular will have, RxJS in context.
Exactly.
Fundamental courses, this is separated from any framework. So you can
Exactly, it's to make framework agnostic.
Svelte, and kind of using both stores or a single thing. You can also control 2 lines to that RxJS observable Svelte store, but also that kind of triggered something. Here are all things that want to happen. Here are the end result. I think it's the most important part. That can be JavaScript.
So in that scenario, you're probably going to have a large amount of long-term. You do a sliding window. I've only used these in that you wouldn't notice memory in the data that's starting over. You have a sense of how this would work on the data set based on the filter to replacing the 10% of our data that we updated.
Need talk currently. It's going to be this right now. For people's dashboard, you have anywhere from few workflows running to right? At this point, I'm stress testing it, up to 120,000, which is still not. It's tricky, but also tricky. So my memory window is really large, but I'm also effectively building an object of data from memory. But the actual I was shocked by data. I basically sat down to one of these benchmarks and expected to come out with this. Down rendering was worse than showing onto the page where I had not, where I was crashing it down too much was a bigger problem than processing. That said, anything is also stuff. So for a lot of these request auto callback is kind of like set timeout or request animation frame, but it's browser. They give you a function call when you're not busy, and you tend to slot into it. If the user's doing something, I won't be refreshing it, right? But if you stop with my mouse for a little bit, hang out for a little bit, then I will go you can even there is, I think we talked a little bit about that, there is a hit from animation frame as well, but even an abstraction of that, there was a first test where we have this request animation frame called next, the next value.
As an iterator, correct?
Base version, but yeah, for that kind of stuff, especially request auto callback, I think it's browser. Yeah, I mean, the docs are also, I think once you get the concept of how to do it, it's just hard to to be clear too, also if you're using it in React, or if you're using it with Redux, right? Redux is also a framework agnostic, has I think Redux observers with RxJS and docs themselves are, I don't know how to get to it from here, but I always know there it is. I can get the creators over here, and then the operators. And then a lot of times I would kind of go through and see each one of these, just kind of figure out. Because a lot of times, like, yeah, these are common problems. You can have weird one-off issues in the code base that are just unique to you and the complexities of the problem you're trying to solve. So in here, you kind of like figure out it as well. So I spent a lot of time on this page, and then also the previous one. These are all like the creators. You can see that like hub is from the operators as well to kind of work through.
You recommend RxJS instead of Redux?
That's a very good question.
Yeah, so Redux Saga is another way to assemble.
Mm-hmm.
I story how we chose Redux Observable in RxJS. Saga. Tell it to me. This was 4 years ago, 5 years ago. We were re-architecting our front code base at the time and going from like Rails and some Flux, or no Flux, and have their own Flux, and then some jQuery, to like, a more modern version of it. And the choices were Redux Thumb, which has gotten better with Redux new Redux release. Anything I'm saying about Redux Thumb, I'm saying about 2000. And then the choices were Redux Saga and Redux Observable. Redux Saga uses generator functions, which, as we saw in the
Exactly. Redux Saga use generator function.
beginning of this course, is not like wildly different in its like syntax, right? Like it has a set of values generated every time, and so on and so on. But it has a little star function, and so it's 4 or 5 years ago. Redux Observable was able to seem about equal at the time. That was a decision-making process. So mostly, I continued to go with RxJS as I'm familiar with it. And it's like we built a very large code base, and that was never the problem, right? And we had to do a lot of questionable orchestration of APIs to ship the features that we would ship when we could make things that we wanted to, and we're basically very quickly able to do that. That does not mean we couldn't get it done in Saga, or we at some point we made a choice. And unlike a lot of technology choices, we made a choice that didn't agree. Right? So if we want to have if they want to
Unlike a man.
a lot of technology choices, we made a choice that didn't agree. Right? So if we want to have if they want
Because this is something that is close to the language, close to the problems that they truly want to solve.
if RxJS wants a testimonial for the web page, I'll happily say we chose it, didn't regret it for doing so, which is the highest praise I think you can do in any technology. Thank you all so much.
Yep. So that'll be all for this video. Take care. Bye bye.